For the next 45 minutes, I'm going to talk about modern infrastructure as code and managing cloud resources with Pulumi and general purpose programming languages. So this topic sounds very much as DevOps, managing cloud resources, creating infrastructure. But I come to this topic from the perspective of a developer. So I want to start with a little bit of background of myself. So I used to be an application developer for sure for many years. And we would work in a small team with IT engineers. We would create an application that would eventually end up on infrastructure in our own data center. So we had a bunch of web servers, databases, and whatnot. And our combined team of developers and IT pros would need to manage that infrastructure and make sure that it's always up and running. And I would be involved in things like on-call rotation, and I would know all the layout of the servers, but still I was just a developer on the team. And it sort of started changing when we started migrating our applications from on-premise data centers to Azure Cloud. And we tried to do everything right. We tried to automate everything. So we created CI/CD pipelines, automated tests, UI acceptance tests, and also we applied the approach of infrastructure as code. So we started describing all our cloud resources as ARM templates. And ARM templates is basically a JSON file where you have a node for every resource. What we found out is that we started using a lot of different Azure services as we migrated. Queues, databases, storage accounts, app services, Azure functions, virtual machines, networking resources, all of that. So our ARM templates grow really fast over that time. And I remember that just for one application, a bunch of web apps and databases, we had like 5,000 lines of JSON files to manage those resources. And creating that files used to be very painful. It's a bit better these days, but two or 3 years ago, it was quite painful. You usually would find something online as an example. You would copy it to your template, try to run it, wait for several minutes until it probably fails for the first time. It gives you a cryptic error, you try to fix it and deploy it again and wait for the feedback for next 5 minutes or so. So this experience was pretty painful for myself, and especially compared to my application development experience with things like unit test, where you get feedback every, say, second if you want to. The experience of creating ARM templates was pretty painful. So I thought there should be another way to manage cloud infrastructure, which would be more native to what application developers are used to. So that's actually the topic of my presentation today. These days I'm a developer on a team called Pulumi. So we develop a product called Pulumi to deploy and manage cloud resources with general purpose programming languages. So I'm here to talk to you, potentially application developers or IT professionals, of how you can modernize your infrastructure as code and use all the great tools that exist for your favorite programming language. My name is Mikhail Shilkov. I work as a software engineer at a company called Pulumi. I work on a core platform, so I work on Azure provider, our Azure support, also our .NET SDK, which I'm going to focus on today, and I'll show both Azure and .NET SDK during the presentation. Besides, I'm a big fan of serverless technologies and also functional programming and F#. If you have any questions after the presentation, you can reach out to me on Twitter at Mikhail Shilkov at any time. Also go to my blog at mikhail.io or email me at mikhail@pulumi.com. The agenda for today is simple. I'll start with introduction of what modern infrastructure as code is and how you can apply your favorite languages to manage cloud resources. And then it's sort of structured around different aspects of managing infrastructure, provisioning, defining architecture, testing, and delivery. And I'll spend several minutes on each one of those topics. Also, I have a very exclusive thing for this talk. It's the very first time when I'm gonna be showing you the new Azure provider that we just released in the end of September. So that's the first conference that a public demo of this Azure provider happens. I believe. So I'm very excited. That's something I've been working on for last several months. Let's get started. First, I want to start with a little bit of background, like where we are in the cloud management, why it's important, why I think the old tools don't cut the goals anymore. So the cloud sort of started 10 years ago or so with virtual machines, obviously. You could take your existing virtual machine and instead of hosting it in your own data center, you would just move that virtual machine to something like AWS or Azure. And sort of this lift and shift approach didn't revolutionize the structure of your application. It would be still VM based, and the approaches to manage those VMs would be highly resembling the previous approach of in your data center. Today, most applications are already created with cloud in mind, so something called cloud native, where you would use something like container orchestrators or serverless functions to create your applications and define the structure of your applications with this in mind. So it's not just lift and shift of your existing architecture, but designing your application from the get-go for the cloud. The cloud still evolves pretty fast, so in 5 years we're gonna be probably using some different approaches, but we don't know yet where we're gonna end up. But even today, the landscape of the cloud is pretty massive. There are multiple tiers that you have to manage, starting from the foundational ones like security, networking, monitoring, and policies, alerting. Then go into compute layers where you can choose from VMs or multiple container services, serverless approaches, manage compute. And on top of that, you need to deploy your application artifacts, so something like Docker images or just a code packaged for your function. And you have to manage state somewhere, so you end up with a bunch of other services like messaging, PubSub, SQL or NoSQL databases, and object stores. If you look at just Azure API, I did the math the other day and I found that Azure has more than 100 of what they call resource providers, so types of resources in their API. And across those resource providers, there is almost 1,000 of resource types. So different small things that you have to manage, or that you can manage as part of your infrastructure that you deploy to the cloud. And the total property count is something like 13,000. So it's a really massive API surface that you have to manage, and that's just one cloud, and there are obviously also AWS, Google Cloud, and whatnot, all the other services. The good news is that with cloud we came to a new level of automation, where all the services that you need to create ever is possible to create programmatically. There is an API in Azure. It's called Azure Resource Manager. It's one layer of API, and you call an endpoint in that API, and several seconds or several minutes later you would get a new instance of a cloud resource. It doesn't matter which tool you use as a front end to issue that command. In the end, it will end up on the ARM API and will trigger the same API from Azure Portal or from AZCLI or some SDKs or a third-party tool like Pulumi. Now, more traditional ways to create a new resource include things like Azure SDKs. Of course, you don't want to make HTTP requests to ARM API manually because that's very low level and error prone. So Azure publishes a bunch of language SDKs for .NET, JavaScript, Go, and whatnot. So you could write code like this, where C# code would get translated to HTTP payload, then would be sent to ARM API, and then in response parsed into C# objects again and returned to you. But when you write code like this, every line in your code would get translated to one HTTP call immediately, and a response would get back. If you come from more operational perspective, you might be using something like command line tools or PowerShell scripts to do effectively the same tasks, and that's sort of the same level of abstraction where You issue one command and it gets translated to one API call. There is a bunch of issues with this approach though. It's very imperative, so in order to create multiple resources, you have to define step by step the exact execution process of what needs to be created or what needs to be updated. And it's sort of okay when you just create a new environment, but then your environments probably live for weeks or months or years, and then you end up creating a lot of upgrade scripts where you need to migrate your existing production environment from its current state to some new state that your application requires. So you end up with a bunch of those upgrade scripts, and also they have to take care of multiple environments that you may have. Maybe your staging environment is not exactly the copy of production, so you start having things like if statements there, and it's quite complex to manage over time all those upgrade scripts and merge them if you need to, or don't merge and keep collecting them, and then creating a new environment becomes quite complicated. Also, scripts and SDK programs are sort of error prone, so if your program fails in the middle, you don't really know if you can run it again, if it creates duplicate resources, or some assumptions will fail, or if it will run successfully. And testing them in advance is almost impossible for all error scenarios, because they are operating on that level of single HTTP responses without knowing the previous history of the environment. So instead, quite a long time ago, the approach called desired state configuration was formalized. And the idea is that instead of defining the steps how to get from state n to state n+1, you describe your target state of the environment, like one definition of the perfect environment. And then there is a tool in there looking at your target definition, and then it can compare it to the actual current definition, current state of your environment, compare those two and figure out what kind of difference needs to be applied so that the current state is migrated towards the target. And then what happens is that over time you only tweak a little bit your target definition, but you never think of upgrades mechanics. You just evolve the target definition, and then it's the responsibility of the tool to apply the differences every time something changes. And a useful way to look at those states is to define them as graphs, basically. Graphs of resources, where every node in a graph is one resource that needs to be deployed, and edges or arrows in that graphs are dependencies between resources. Dependencies are important to figure out the exact execution order and what can happen and what can have effect on other resources. So in this example, our current state is missing one resource compared to target state, so the tool can compare them, figure out that there is a new resource to be created, and there is no obvious dependency on that resource yet, so it's a simple operation of just creating a new resource in this case. And the state-of-the-art tools in pretty much all clouds already operate in this desired state configuration mode. So maybe you are familiar with Azure RM templates, where you define your target state as a JSON file, and then you send it to the Azure cloud, and Azure cloud compares it with the current environment and figures out what new resources need to be created. It's sort of not perfect sometimes because it cannot create difficult migrations of deleting old resource and then doing something else and recreating it again, things like that. But the idea is the same. Kubernetes is all built around desired state configuration, and it's usually defined as a YAML file or something on top of YAML, like Helm templates. And maybe you are familiar with Terraform. They invented their own language to define desired state configuration called HCL. But you can see that all these tools are sort of similar. The formats are a bit different, but they are all based on text. So you create a text file, either YAML, JSON, or HCL in this case, and then that text file is the target definition for your environment, and that's what you are working with. Now the text files or markups, they have their own challenges. First, because they are custom formats. When they are just released, there is no tooling existing for them. It's just JSON or YAML for a tool. It doesn't know about the resource model. Another example, Microsoft just presented Project Bicep, yet another markup language which in the tooling basically doesn't exist for it. They have to start again and start creating things like VS Code plugins so that your authoring experience would be more or less smooth. Second is that discovery is sort of problematic. You usually end up finding some examples online and copy pasting them into your markup and then tweaking them to your needs instead of just authoring from scratch. And because these markup files operate on a low level, usually the size of the definitions is pretty big. So if you create your ARM templates, as I alluded in my introduction, you end up with lots and lots of lines of JSON because there is no first-class level to create abstractions. Just an example in this sense, I compared several implementations of a serverless URL shortener, so something like aka.ms or bit.ly or tinyurl.com, where the application is very simple. You go to one URL, it looks up in the database your URL path, and then if there is a full URL associated with this path, it redirects you to the full URL, right? So the application code for the basic implementation is like 20 lines of C#, right? Look up one key in the database and redirect the response. But in order to create all the resources in Azure or AWS, you have to define like order of magnitude more markup. You have to define app service plans, you have to define storage accounts, some database permissions for them, endpoints, Azure functions, or in case of AWS, there is a bunch of resources. So you end up writing much more code for infrastructure compared to your application code. And that's of course not what I want to do. I want to write my application. That's where all the business value sits, instead of just creating those markup files. So that's the goal that we want to solve in Pulumi. And the way we solve the Pulumi is that we use the same desired state configuration for cloud providers, but instead of using markup languages, we use general purpose programming languages. At the moment we support 4 runtimes, so Node.js with JavaScript and TypeScript, Python, Go, and .NET Core, all the languages of .NET, and that's what I'm going to use in this presentation because we are talking more of Microsoft technologies. So I'm going to use C# mostly, but we also support F# and VB as well. Pulumi is by design multi-cloud tool, so it's not just Azure. I'm going to show you all the Azure examples today, but keep in mind that everything that I show you can be applied to AWS or Google Cloud, or even smaller clouds like DigitalOcean or Cloudflare, or even not exactly cloud things. Every tool that has API and the notion of resources can be a Pulumi provider, and in fact we have like 40 or 50 providers at the moment. So you could manage your Docker images, upload them to container registries, deploy them to Kubernetes, create it in Azure, all from the same program or same set of programs in Pulumi, and put like a dashboard in your egg on top of that, which is quite powerful. So that's the first example of a Pulumi program in C#, or rather a snippet, not a full program, where we create 2 resources. The first one is a resource group, and you can see that that's just an instantiation of a class, so creating a new object, giving it a name. That's the definition of a resource. And then the second one is a storage account. It gets a bunch of properties, and one of the properties is resource group name, which uses the name of a variable resource group and then taking a name property from it. And just by the fact of using that variable inside the definition of a storage account, that's enough to create the link between these 2 resources, so that the tool knows the exact order that it has to create those in. So it would start with the resource group. When it's created and its name is known, it will start creating a storage account on top of it. And the most important thing to understand here is that this code is still desired state configuration. So as it runs, it doesn't issue the requests to API immediately. The result of the execution of this program is a graph of resources that targets state definition that the engine gets, and then it compares that graph to the current definition, and only then it figures out the exact sequence of API calls and starts provisioning them. So at this point I want to switch over to my IDE and show you an end-to-end example of a Pulumi application in Azure. So I switched over to an IDE, which is in this case Rider from JetBrains, but you could also use Visual Studio Code, or anything like that. And I created a sort of a blank Pulumi project in C#. So what it looks like is it's just a C# project, same structure as you know for .NET Core 3.1, and it has two packages, NuGet packages referenced. One is Core Pulumi, and the other one is Pulumi Azure, which is a new provider. We just released a couple of weeks ago, a new generation Azure provider that supports all the resources and all the versions that are exposed by Azure Resource Manager itself. And the project has two C# files. One is program.cs, which is very simple. It's just a console application with a main method, and all the main method does, it calls Pulumi deployment run async and passes it a generic parameter class. That's all. So you could do some initialization here, you could read some config values if you want to, but in this case it's super simple, just one command in the main program. And then the definition of the resources should go here to something called stack. Stack is a class, and inside the constructor of that class you should define all the resources that you want to be deployed as part of this Pulumi deployment. I prepared some snippets so that I don't have to type everything manually. So the first resource to create is a resource group. It's a first class resource in terms of Pulumi model. You can define your resource group inside the same program where you define the resources inside that group. And creating a resource group is just a call to resource group class constructor. Then we give it a logical name which makes sense inside the program, and also we give it a physical name of what's gonna be exactly created inside my Azure account. And then the location is West Europe, because that's where I am. And you can notice that the resource group class comes from a namespace pulumi.azurem.resources, which is the Azure Resource Provider .latest, which means that I want to use the latest stable version. If I really wanted to use some older versions of the API, I have a full choice here. I could pick some version that I know provides some different things, or that I'm already used in other applications, so that I found an example online. But by default it makes sense to take the latest and go ahead, especially for a demo application. Then the second resource is gonna be an app service plan, and my program in the end would deploy an app service which would run a Docker image container. So in the end we'll get an URL that we can hit and see that everything is up and running. In order to deploy an app service, I first need to deploy an app service plan. And here I am using the app service plan resource, giving it the resource group name where I want to deploy, then the actual name of that resource, its location is copied from the resource group, which makes sense. And then I want to make it Linux, I have to say kind Linux and then reserve true. That's the exact copy of the model of the ARM itself. And then I say the SKU for this resource is basic tier, and B1 is the instance size that I want to provision. And my third resource is gonna be the web app. So I want to deploy a Docker container. I define an existing image from Microsoft for the demos, the app service deployment with Docker. And then my third resource is web app from web namespace again. And the same structure, I pass it to the resource group, name, location, the name of the app, then I point it to the app service plan that I just defined above, its ID to be precise. So server farm is sort of a legacy name for app service plan, but it still holds in the API, so I need to define server farm ID here. And then a bunch of configurations. The main one is basically this Linux FX version, which is the way to point app service to a Docker image in the standard registry. And I say I want to use only HTTP. Yes. Finally, I need to export something from my program, because I don't know which exact URL or rather hostname app service is gonna define for me for my application. I need to take that output from the resource, which is not existing yet, I need to take the default hostname that the web app would define after it's created, and then format it as a URL that I can access from a browser or command line tool. So here I am. For this I need to define something called an output in my program. I define a property in my stack called hello endpoint, so endpoint of a hello application, and then it has a type of output string, so I expect a string, and I assign a property from default hostname, formatting it with interpolation, adding HTTPS and the hello as a URL. So that's all. That's my program. I can build it, and then I'm switching over to the command line to actually start deploying that resource. Now I am in my command line tool. You can obviously tell I'm using macOS, but you can also use Windows or Linux as well. And I have Pulumi CLI installed. This is the tool that I need to use in order to actually make the deployment and deploy my resources to Azure. So I type Pulumi up command while being in the same folder where my C# project is located. And what it does is that it compiles my build, it builds my project, it runs it, but it doesn't deploy anything yet. It shows me the preview of what is about to happen after I hit yes in the menu. So it shows me a preview. It's gonna create a stack, which is like a container for resources deployed together. And then it found that I want to deploy 3 resources: a resource group, app service plan, and web app. And it asks me if it makes sense, and I say yes, of course it makes sense. And now it runs my program again, and this time after the definition of resources is created, it will go ahead and start deploying them with issuing actual requests to Azure Resource Manager API. So it starts with a resource group which is already created, and deploys an app service plan. And you can see that web app is not being deployed yet because web app depends on the app service plan, because we referenced its ID in the definition. And when the plan is created, the actual web app goes and deploys as well. After this is done, I should see the output of my program, and the output would point me to the URL of a website that was created with the app service web app. So this is done now. I opened the browser to point to that URL that we provisioned, MS Stage Demo App, hello. And I got the hello world, and that's what the Docker image, the sample Docker image that we used returns as a response to the URL. Now I switched over to my IDE again, and I want to show you how I can change this program and deploy it again, and what it looks like. So for example, I want to add some tags to my web app, and I can say it's my environment is production. Of course I deploy the production the first time, sorry for the typos, but you can see, say if I make a mistake here and misspell a name, it will give me red squigglies, it gives me IntelliSense, so I get all the tooling support from my IDE while doing so, and immediate feedback when I change something. Switching back to the CLI, I can type Pulumi up, same command as before, and again it runs my application after compiling it and gets the definition of my desired state configuration, but this time it compares it with the existing state of my environment because I already deployed something. And now you can see that this time it figures out that it needs to change the web app with tags, updating them in place, but it doesn't need to change any other resources or deploy anything else. And I hit yes this time again. It says it will update the web app with the tags, and when this is done, my desired state is equal to my current state again. And that's the responsibility of the Pulumi engine, the Pulumi CLI, to reconcile the current state to target state as often as I changed it. So that's the idea of the desired state configuration in action with Pulumi. So that was the demo of how Pulumi works. I just want to quickly reiterate on what exactly happens when the deployment runs. So Pulumi has multiple components that interact to each other while deploying your application. First is a language host. It depends on the runtime that you use. We use .NET, so in this case it's going to be program.cs plus my stack.cs. And the language host calls .NET to compile that program and to run it. And the result of the execution of that program is nothing but the definition of the resource. So more or less a graph of resources with properties. Then this graph of resources is passed over the wire, over the local gRPC interface to the CLI, to the command line tool that I showed you, to the engine of the whole deployment. And then the engine takes that definition, loads the last deployed state of the environment and compares them to each other. And then it figures out the difference. During the first deployment, the difference was everything. So it figured out that it needs to deploy 3 resources in sequence. During the second deployment, the difference was just 1 resource. So that's the command that the engine issued to the actual provider. And the provider, we have a separate component, a separate provider for every cloud. Then CLI issues a command to that provider, and provider knows how to translate it to the actual API calls with all the authentication and formats and whatnot that goes with this. So it issues the REST API call to Azure, gets the response back, passes it back to engine, and now engine knows that the current state is already up to date, and next time it will be comparing it with this updated definition of the last deployed state. Now, you probably already noticed, but I just want to reiterate that you want and you can use all the favorite tools that you are used to in your favorite programming language and environment for Pulumi programs. So if you are a .NET developer, you are using .NET Core 3.1. When .NET Core 5 is released, this is going to be supported as well. Any operating system, any language that .NET supports, also any IDE from Visual Studio Code to full Visual Studio to Rider, and get all the IDE tools as well, something for refactoring like ReSharper, linting, generating docs, any package manager that you prefer, probably NuGet, but also if you are a F# person, maybe Packet, and unit testing tools as well that I'm gonna show you in just a second. So you can deploy resources with C#. I already showed you this before. You can also use F#. Even if you don't know F#, you can see that the shape of this program is more or less the same. It's just that the syntax is a bit different. But the idea is the same. You instantiate objects in F#, and that gets translated to the graph definition for the engine. If you use VB.NET, I'm going to be a bit surprised. Not many people use Pulumi with VB.NET yet, but you can definitely use this with the same possibilities as C# or F#. Now, why I think it's a great idea beyond the tools. The most powerful aspect for me is that you can start creating your own abstractions on top of raw APIs. So Pulumi SDK provides access to all resources inside ARM API surface, but it's the same abstraction level as ARM templates operate, for example. But now if you have a pattern in your application that you use again and again, or across multiple teams in your organization, or in a large open source community, you can start defining classes or functions or modules or whatnot, namespaces, NuGet packages, whatever, to define reusable abstractions on top of that raw resource model. So for example, in order to deploy a simple Azure function, hello world function, it's sort of similar to my previous example, but you have to deploy a storage account because that's required for function app. You need to deploy your binaries of that Azure function to a storage container in a blob. You have to deploy an app plan, app service plan, and you have to deploy function app, and all of this goes to a resource group. So instead of defining them again and again and again in every application, you can go ahead and create a component. That's what I did in this example. I created a component called archive function app, which basically deploys those 5 resources for you on your behalf. And you just need to say, this is my resource group, and this is the path on my disk to where my Azure functions reside. And that's it. You just go to your command line tool, you run Pulumi up, and what you get is a preview like this, where you see your archive function app at the top layer, and then you see that that component contains 5 resources that are required for the function app to function. And now you debug this component once, and then you share it with your teammates, and everybody benefits from using the same component. You can make it as simple or as complicated as possible. It's just C#, so you can use all the knobs and tools that are available in C#, all the conditionals and loops and strong type configuration and whatnot. So in this example, by default, my archive function app deploys .NET Azure functions. It makes sense because I'm using C#, but maybe I want to define functions in JavaScript but deploy them from C#. That's possible. Then I get an extra parameter called runtime equals node in this case, and then I point to a folder where JavaScript functions are, and that will package the JavaScript function and also set all the right configuration values on function app so that it knows to run Node.js instead of .NET. Say I need to deploy Python Azure functions, which is also possible, but Python Azure functions only work on Linux app service plan or Linux consumption plan. So in this case, to use my component, I have to define a separate app service plan because the default one would deploy to Windows and Python wouldn't work. So I define a new app service plan called kind Linux reserved true. Tier is dynamic, y1, configure all the values properly, and then I can pass this extra parameter called plan and use my Linux plan as the value for that parameter. And then my component knows that if there is an explicit plan passed as a parameter, please don't create a default Windows plan, but use that one instead. And then I say runtime Python, pointed to a folder called Python, and then my Azure functions in Python would be deployed to a Linux plan that I just defined. I could as well define Linux premium plan or Linux app service plan, so I still have all the flexibility that I want. But the user of my component is just like writes 5 lines of code, defines only the different configurations that it wants to use from defaults, and then the usage is very simple and abstracted away all the nitty-gritty details of the provisioning. And obviously you can use it to any tier of imagination. You just create new classes, new NuGet packages, share it with your colleagues or to open source community. Now, the next powerful thing is that you can start unit testing your application. So a more typical way to test deployments in the cloud is to actually run the deployment to some test environment, then run automated end-to-end testing through UI or API calls, and then destroy that ephemeral environment again so that the test passes or you report the failure if it happened. But that's really slow and also error prone. Maybe Azure has a bad day, something fails that you couldn't affect. Instead, or in addition to, you can also start unit testing your program definitions. Because you are in C# or in JavaScript or in Python or whatnot, you can write a small piece of code that would validate the shape of your resources without actually deploying them. That's an example in C#. Instead of calling deployment run as we did in the demo application, this unit test in any unit calls deployment.test async. That's the first line of the body of this test. And this doesn't deploy anything to Azure. It doesn't even try. It just returns back the graph of resources that I was talking about. So it returns a collection of resources as defined inside the stack. And now it's all in memory, so you can inspect it as you want. In this case, I find the resource group in that collection, and I make sure that there are tags there and there is environment tag. So this test would obviously fail for my demo application because I didn't have tags on resource group, but I had tags on web app. It would fail in like 10 milliseconds. You can have 100 of them or 1,000 of them, run them on every commit or even on every change on your local environment, and use that flow from application development that you're used to validate also your infrastructure. Another more complicated example, I found it in our examples, so it's in TypeScript, but doesn't matter, you can also do it in C# if you want. It sort of validates the Cosmos DB account that is deployed on multiple regions. And it validates that first there are multiple regions, but also that the distance between two regions is at least 500 kilometers. because maybe that's required by your organization in order to provide proper disaster recovery protection. So it goes through in a loop a list of Cosmos DB locations, calculates the distance by just looking at the latitude longitude of those locations as published by Azure, and if it's at least 500 kilometers, the test is green. If not, the test is red. You can do this kind of powerful stuff that are almost impossible to test with like JSON templates or something like that. And if you want to learn more about unit testing.net, I have a blog post published which goes through all the mechanics of unit testing and how it works with .NET and Pulumi. I'll have links at the end of my presentation. You can also bring it sort of to the next level, where instead of just writing a unit test for one program, you can define those rules as a policy for your company or for your team, and then enforce that every time something is deployed in your company, that rule runs before the deployment, and if it fails, the deployment will stop and it will not happen. So it's good for things like security, where you could define that you never want to expose SSH ports to public internet. And you can codify this once, or even take the existing definitions that we provide or somebody else provides, deploy it to your company infrastructure once as a policy, and every time a new application tries to deploy something, this rule will run, and make sure that you do not expose SSH ports to the internet, so you don't get vulnerability across your stacks. It doesn't matter what happens. And the power, of course, is again that you are using general purpose programming language. In this case, it's again TypeScript, because policy as code is currently only supported for TypeScript and Python. But we define rules as complicated as you need to, and it's not just a JSON configuration somewhere. It's your code that you maintain and support and test and validate, and once it's deployed, it's enforced for all the deployments in your company. Quite powerful, right? So, time for conclusions. What have we learned? Well, our goal as Pulumi is to provide modern infrastructure as code capabilities to application developers and IT professionals, DevOps professionals of today. So we bring those people in one team, provide the tool that most of them already know, from languages like TypeScript or C# or F# to more ops-oriented Python maybe. And we say that, hey, now you can use all the familiar features and tool chains to also bring the best practices of software engineering to infrastructure definition and cloud management. Very powerful approach is to treat your infrastructure code on the higher level of abstraction. So create components, reuse those components for multiple teams in your company, encapsulate logic there, use anything like conditionals or loops or classes or polymorphism and stuff like that. Package this into a package in your favorite package manager and distribute it across the board. And also apply the best testing practices to your code, from unit testing to integration testing to acceptance end-to-end testing, all with general purpose programming languages to ship faster and with confidence. Typically, these capabilities are very powerful for example, for companies that have multiple teams working towards the same goal, and then there is a team which is more experienced with infrastructure provision and automation, and then that team can take a lead there and sort of codify the best practices for all the teams, create a bunch of patterns, and then package those as a distributable packages, and sort of provide a platform for other teams in the same company of components that they can build off. So there would be a central repository of components, and a new team comes, hey, I need to deploy a SQL database and web app, what are the best practices here? Here you go, these 5 components that you need to use, or this 1 component that you need to use from our central team. Just take them and don't be blocked by learning too much details of that. Just understand the high level how to use this, and these components are tested and well maintained by a central team. Also imagine that you need, for example, to provision a new instance of the infrastructure for every customer, for every tenant that you have in the system of your SaaS product. So that's also a very important scenario. If you want to get the links of these slides or go visit other blog posts that I have for you to share, please go to this link bit.ly Pulumi links, and you'll find my slides there, my contacts, and other useful links for Pulumi and Azure and .NET. With this, thank you for listening. I'm happy to answer your questions today, or feel free to reach out to me later on and ask your questions about Pulumi. Thank you and have a great conference.